from University of Rhode Island. He's an expert in all the statistics, especially inflation. And then Professor John, he's one of our young faculty members. So he joined GISE, I think several years ago only, I believe. And he's also a talent in AI, structure, equation, SEM, all that. So he's also currently supervising another doctor student with me. Okay. So thank you so much for joining the oral examination for serving as a committee member of Dadan's master thesis. So according to our GIS's protocol, okay. So I confirm we have recalled the oral exam, and we have enough person. We have three of us are here now, and we need to recommend one chair. So usually we will recommend the one outside the department. So Shen, could you follow the lead? So I'm gonna hand it to you now. 好，谢谢。
So what I'm going to do is ask the postgraduate students and observers if there are any to withdraw. So Jim, you can confirm.
Okay.
Dada, or anyone else that's in the room.
Okay.
And we can discuss the written document, the quality of the written document.
Okay, right. So you guys, you stop the recording. So Dadan, the way we set up, Shen and John, they couldn't see you. Could they see you?
See me? Here?
Yeah.
No.
I think you need to, yes.
Yeah.
Right. Yes, yes. Okay. Right. Alright, so Jen, it's all yours.
So the next phase of the defense will be Dadan will present, give an oral presentation of key facets of his thesis work that will highlight the main points of that work. Immediately after which, the committee will engage in question and answers regarding the oral presentation and the written thesis that Dadan will answer. So ready when you are, sir. Yeah.
Alright, I'm going to present the thesis, master thesis that I write. The title is Implementing Base Theory to Analyze Interactive Web-Based Scientific Inquiry Assessment, Inquiring Temperature Graph on Atmospheric Climate Change Issue. So there are no doubt anymore, climate change is happening and has already been confirmed by scientists. Teachers need to take action in class to spread the awareness. We need to talk about it in class. Education is a way to educate people and can be a good way to prevent climate change before the tipping point, which is plus 1.5 degrees Celsius. Tipping point is a critical threshold or a point of no return in Earth climate system, which is potentially irreversible. We have science lesson. From an early age, student in formal school has been taught how to interact with nature through natural science lesson. We have physics, we have mathematics, we have chemistry, biology, but have we made sure that the lesson is appropriate to teach interaction with nature? Or does the natural science lesson actually lead humans to legalize some things on natural exploitation? Does the content of natural science really represent the pro-nature? So the thesis organization of my master thesis used 3 issues within 2 articles using a sandwich thesis format. The main issue here is about climate change crisis, which is we answer by climate change awareness. And then we have 21st century crisis, we answer by computer-based assessment. And then we have replication crisis, which is we answer using Bayesian statistics in a case study of scientific inquiry. The first article is about revolutioning scientific learning, innovating interactive web-based assessment for scientific inquiry. Science education reform is happening worldwide to facilitate student scientific inquiry ability, which aims students to understand how scientists do their work. The different scientific inquiry assessment, they have the process involving students in the process of understanding. They have observation, question, hypothesis, result, and conclusion. Recently, rapid expansion also happened, integrating scientific inquiry into computer-based assessment, which also can measure complex inquiry skill more effectively. In the first article, there is a question is about, we will explore the capability of scientific inquiry and construct validity of the assessment. The demographic characteristic of students will also be investigated. There is a question 1, what step may be taken to create an interactive web-based evaluation that provides complete and ongoing information about student scientific inquiry ability? We will apply RAS model analysis here. The number 2, are there any difference in scientific inquiry ability among demographic characteristics of high school students, which analyze using Bayesian inference? About scientific inquiry ability, according to NRC, humans are curious. We try to predict what will happen next, check and recheck, and compare results to what we already know. That term refers to inquiry. And then the communication of hypothesis, idea, and concept among individuals shape the strategy, rule, standard, and knowledge. That term refers to scientific. According to our knowledge, scientific inquiry has a lot of terms. Some research say it is scientific inquiry competency. Some people say inquiry skill. Some people say science practice. But overall, they are referred to one thing. And the most appropriate way to learn science is to adopt scientists' way of working, according to the Board 2006, which is referred to scientific inquiry. Interactive web-based assessment in this term is an innovative type of assessment that blends computer-based assessment, multiple media format, and interactive tasks to measure scientific inquiry ability. And multimedia, example animation, video, and virtual reality, students are immersed in virtual environment in which they must complete tasks or achieve objectives. We also have something problem with science denial and disinformation recently, because although activity of inquiry-based science lessons are really good approach to begin scientific investigation, humans also have tendency to disregard, to avoid information that contradict with their ideological identity. The resulting polarization over science has reached alarming level in recent years. For example, in recent phenomena like climate change. We also discussed about the nature of scientific inquiry assessment on climate change. According to record, they make term like science polarization, which has risen dramatically over time, that can also be observed globally for other scientific other than climate change. For example, we have vaccine polarization and other science issues. Further, BOOS also recommend to create and refine curriculum that utilize geospatial technologies, climate model, to involve students in direct communication, to bring students into contact with scientists, climate data, authentic anthropogenic global change issue. In order to develop the assessment, we adopt the framework from NRC in 2000, which was adopted by Kuo at 2015, including in scientific inquiry assessment, including the questioning, experimenting, analyzing, and explaining. And the refining the greenhouse gas issue is the current inquiry assessment. We focus on explore the time temperature curve in carbon dioxide and methane. This is one of the framework that we create, which is inquiry ability consists of questioning, experimenting, analyzing, and explaining. But in scoring, we only focus on analyzing and explaining, and questioning and experimenting on the step of the assessment. This is one of the assessment that we adopt. We use questioning, experimenting, analyzing, and explaining. We have experiment 1 as representative of experimenting, and then we have A1 as part of analyzing. We apply RAS model and Bayesian statistic here because PISA applied the RAS model also. They say it can be used either when developing new instrument or when evaluating or replacing existing one. Another term that we use is Bayesian statistic because traditionally whether the alternative hypothesis is significant or not is decided using the p-value. However, many people, scientists have relied heavily on p-value, which is currently being criticized by quantitative methodologies, and various alternatives has been proposed. Even some journal makes some statement to banning p-value from journal. In the case of classical inference, we use p-value. For example, p-value less than 0.05, less than 0.01, or less than 0.001. In the case of Bayesian inference, we have Bayes factor, which indicate the strength of evidence supporting alternative hypothesis instead of null hypothesis. In methodology, the participant is student in 11th grade. Data used for the analysis is almost 14,000 students from natural science class and public school in southern China. They classified by gender and school area. In order to do the assessment, students are given basic instruction on how to use the classroom, and then perform the assessment for several minutes. Once they finish, they can start systematically starting from SI1 to SI6. In order to answer the research question 1, we use Jamovi, and the threshold we adopt by Arnold in 2018. We found that nearly all aspects has acceptable value. Only one item has mean square is bigger than 1.5, which is item SI2, which was excluded from further analysis. Item 2 was one of the easiest items for the respondent with a very low sensitivity. We also have the cumulative curve with observed probability and expected with a lowest discrimination and best discrimination. From this graph, we know that SI2 is the lowest discrimination probability, which is the left side, and the orange color. That one is SI1. And then SI6 and SI5, they have best discrimination probability. To answer the research question 2, we use just software according to the demographic characteristic regarding scientific inquiry ability. We have a graph comparison between male and female, city, county, and rural. According to Bayesian model comparison, we use just software, which is the easy software for Bayesian statistic inference. The value of Bayes factor here, BF10, it means Bayes factor for Alternative hypothesis, again, null hypothesis on gender is 449, which means that the observed data support 400 times more for alternative hypothesis than for the null hypothesis. Scientific inquiry ability among school area also show that there is very strong evidence to support the alternative hypothesis. We used the threshold by Cass and Raftery in 1995. 2 log BF equal to, it is positive evidence, and then in our data we have 2 log BF, male and female is 5. And for the city, county, and rural, we have 2 log BF is equal to 200. Compared with other finding, our research is paired with other scientific inquiry in assessment research. For not similar finding, we found that Ilham and Johnson in 2016 report that gender is not the main predictor of understanding scientific inquiry in Turkish kindergarten. Age, family income level, and the number of brother or sister is the main predictor. According to Chupas in 2005, performing science inquiry intervention in elementary school in certain US, they found that male achievement was lower than female in the pretest, but male gained more during the intervention and then got the highest in the process. While we have similar finding according to previous research, according to research by Chi in 2018 in China, compared with their female friends, on average, male student has higher science achievement and had more positive attitude towards science than female student. The reason why maybe can be explained by 2 explanations. Number 1, in Chinese culture, according to Chi and Zhou in 2014, they say in Chinese culture there is a perception of higher significant place on male offspring, particularly in rural area. In that it can result in make some priority for their son's education when facing financial struggle. In some case, poor family may not even send their daughter to school. The second explanation, maybe it can be also could be that the level of male disruption behavior is rare in that case. According to Kaplan in 2002, at the student level, being male and having lower achievement was related to disruptive behavior. According to different area, we found that urban, city, and county has different. It also supported by Zhang in 2015. They say inequality between the rural and urban area in China has been reported to have significant gap in education performance. In conclusion, for the Article 1, the item of student scientific inquiry ability contain item with validity with high discriminant power that could serve as tool to distinguish between high and lower performing students in climate change issue. Number 2, using Bayesian inference, we conclude that being male student and student who attend school in city has a higher probability of understanding inquiry in climate change issue. The second article discussed about Bayesian multi-level model analysis on scientific inquiry ability. So in second article, we focus on applying Bayesian using R Studio. The replication crisis is a hot issue that is widely discussed among scientists. This replication crisis is marked by difference between the latest result and the previous result. So maybe some people asking like, is it normal to have different result in similar study? Our understanding in frequentist analysis, which is term of objective probability, which in theory should not differ from one another in one population. We have replication also in education. Rate of replication in education research are very low, albeit slowly increasing, with approximately 2/3 of replication being conceptual or approximate, and rate of direct replication is even lower. Nowadays, many scientists in education mostly pilot frequencies analysis because not many studies report the linearity, normality, homogeneity test as formulated based on the central limit theorem, which is the main basis of the p-value that determine the null hypothesis significant testing. In frequencies, we have linearity, homogeneity, and normality, which is one of the basic of linear model for t-test, ANOVA, regression, and ANCOVA. The aim of this research is sampling distribution of the mean will always be normally distributed according to the central limit theorem, regardless of whether the population has normal, Poisson, binomial, or any other distribution. Thus, this research will focus on implementing Bayesian analysis using R, as well as analyze the sampling distribution of this data. The idea that scientific study can be replicated is fundamental to the rhetoric of scientific method, that science is self-correcting, which will identify the incorrect finding. The preferences, they rely on applying estimation and inference, also null hypothesis significant testing, and the construction of confidence interval. And for the Bayesian, they rely on Bayes paradigm of conditional probability and adjust subjective a priori into posteriori statement after observing the data. Scientists are uncertain about many things. The uncertainty can be quantified as probability. When new data arrives, Bayes theorem tells them how to move from the prior probability to new conditional probability. We have two questions in this research. This study will demonstrate and implement Bayesian statistics to analyze scientific invariability among students in China. Research question 1, what properties of variance is explained at student, class, school, and district level? Number 2, do students with longer testing times or higher adjusting for gender? In methodology, the participant is 11th grade student, consists of 30 students from natural science class and public school in southern China. And for the item, we have SI1 until SI6, but SI2 we are excluded from this analysis because according to previous article, it has low discrimination power. So the the participant is classified by class, school area, gender, nature of resident, and household registration. According to our analysis, our data is clustering by level 1, level 2, level 3, and level 4, which is level 1 is individual. They have inquiry test and duration time, and in level 2, they have average inquiry test in class 1, 2, 3. We have 7 district, 12 school, and almost 200 class, and 30,000 students. So in Bayesian multi-level model, according to Mark Elric, multi-level model, also known as hierarchical random effect, varying effect, or mixed effect model, built as diverse as educational testing and bacterial phylogenetic now given on routine multi-level model to process the data. In order to measure the outcome, we apply two parameter model in order to understand the scientific inquiry ability, which is in this case is non-observable or latent variable. And then we have observable variable, which is scientific inquiry test and score. So we want to know the student responding to inquiry assessment represents scientific inquiry ability. So we perform RAS analysis. Here we analyze M0 and M1. And we have the conclusion that two-parameter model, 2PL or M1 and M2 is significant. Two-parameter model outperform a one-parameter model in this case, which has much lower AIC, BIC, and deviance. The model 1, the model M0 is the simplest RAS model, and it assumes that the items on a scale are unidimensional. And then we focus on, because we have model M1 significant, so we conclude this model is single latent dimension with 2 PL model. We also perform person correlation with scientific inquiry total score and latent variable, which means that 96% of variability of total score is attributable to latent trait. So they have correlate each other. And then we have time span and total score. Using the person correlation is 0.56, which means 31% of the variability of the total score is attributable to the testing duration. Using data analysis plan in this patient, model fitting is conducted in 4 steps. Number 1 is specify a joint distribution of the outcome. Number 2 is draw from posterior distribution via Markov chain Monte Carlo simulation. And number 3 is evaluate model fit and analyze manipulation of predictor and visualize the result. Number 1 is fitting the likelihood of the data. First, we use in the left side we use Gaussian distribution, which is the linear model. But we found that the model is not fit with our data, so we use Poisson distribution, and then it fit with our data. Basically, we use the truncated Poisson model, and it is more suitable in our data. We use Poisson distribution in this case. According to model fitting result, we can see we have mean value of posterior, we have intercept in class level, school level, district level, and we found that in the left side show plot of regression coefficient on arousal, and the right side show the 3 chain appear to be the same, which is a strong sign of convergence. Research question 1. What properties of variant is observed at the class, school, and district level? So this model explains 43% of the proportion of the total variability in the dependent variable, which is total score in inquiry assessment. And if group level information was excluded, which is clustering by class, school, and district, the model only explained 24% of the variability is less than the full model with clustering. And then in the result, we have the estimation in district, school, and class, and then we have the variance of all the clustering. We have 12% of the total variability in student test score. It includes 67% of model variance between district, 22% between school, and 4% between class. So there is a marked variability in student test score between district and school, but the variation is smaller when comparing individual classroom within the same school. In the discussion, this implies that factors specific to individual classroom, such as teaching style, classroom management, or teaching-student interaction, may have smaller impact on variability in student performance compared to broader factors related to district and school. The finding confirmed by another study by Wright in 2012. They found that American public education in suburban area is significantly better than in urban area, which is in district level. And then this disparity between district and school sector in education is drastically different due to research, teacher attribution rate, and lack of parental support, according to Wright 2012. And using multi-alpha Bayesian regression, it can help identify area where improvement may be necessary, targeting intervention at different levels to enhance student performance. However, we found some good implication from Flores in 2007. Flores mentioned that we often see some statement like student of color continue to lag behind white student and some Asian student, and so-called academic achievement gap is still exists. That term refers to blanket statement. Blanket statement is kind of surface statement about some issue regarding the achievement gap. Blanket statement about low performance of student group without mentioning the underlying may trigger some stereotype image of some group, which is also not good in educational research. So we need to pay attention with this issue as well. So this is question 2. Do students with longer testing time score higher? Adjusting for gender. So the main estimate value are positive for time, which positive relationship between the duration times and inquiry score. While it also shows some negative value for gender, especially for female. In posterior prediction, we have the conclusion that comparing the posterior prediction for students with average mean 0 and high, which is mean 2, in time spending testing, the analysis found that students who took longer score almost 2 points higher than their friends. We are 86% confident in this estimate given the data and the model. Several reasons to explain why testing time has the effect on scientific inquiry score. It can be explained by two explanations. Number one is stronger problem-solving skill, and number two is a deeper understanding of the subject matter. Number one is taking longer may indicate that students pose stronger problem-solving skill. They might be using the additional time to make some strategy, analyze the complex problem, and select the most appropriate answer. According to both Hammer in 2014, they conduct research in German about assessment of adult competency. They found that in problem solving, which required controlled processing, the time on task effect was positive and increased with task difficulty. Number two is a deeper understanding of the subject matter, in which students will spend more time on the text may have more comprehensive understanding of the subject being assessed. They might have a deeper knowledge base, enabling them to apply critical thinking and make more informative answers. Other factors such as test anxiety or test-taking strategy may also influence the result and should be considered in future research. So in conclusion, there is marked variability in score between district and school and less so between classroom. And then adjusting for gender, students will take longer to complete the test, score almost 2 points higher on average. And the general conclusion of my thesis, we have the climate crisis, which is to refer to long-term change in Earth climate, including methane, CH4 in this research. We need to spread the awareness in the class, which is necessary. And then for the 20% learning crisis, the technology can be a key tool in addressing the 20% relearning crisis. And then for the replication crisis, Bayesian is a statistical framework that can be used to help address the replication crisis in science. Thank you for your attention.
Okay, and so with the conclusion of that good solid presentation, we're going to move on to the chair, or the committee, I should say, engaging in question and answer around the thesis work. I'm going to recuse myself until last, because I have Bayesian methodological points to make that are very technical. They may actually overlap with some of the statistical questions that Professor Lin has. So I'll open it up first to the major professor, Professor Chung, and then we'll have Professor Lin and then myself.
Okay, so I will start my part. Okay, so Dadan, I think you are the first, my first graduate student doing your thesis purely using Bayesian. So I think this thesis, if it can be revised, based on the recommendation of committee members, it's going to be a must-read Bayesian analysis for my following students. I think you have done a good job now in terms of reviewing everything. So I have actually only several minor questions for you and one quick comment. Okay. So regarding the second study, okay, the research question. So you actually try to the second question to students with longer testing time score higher, adjusting for gender, right? So do you think that are there other factors should also be adjusted, not only gender? Do you think consider other factors? Because I believe we do have collect not only school, district, all that. So maybe are there possible other factors? But maybe we didn't get the data. But according to what you have done here, so right now you are only at the student level, you only adjusting for gender. Any other possible factors might be considered, okay? So that's the first. So then I have several minor things, like on page 49, the second paragraph, you were describing the data used for analysis in the last version consider 1,000 students from a natural science class in a public school in southwest China. So I think the description is not correct, right? Because you are actually talking about the students are from one class. But actually one school has several classes, right? So maybe, when you describe the things, you probably also need to describe correctly. And on page 51, the figure 4.2, the hierarchical data about the scientific inquiry behavior in China. There are 4 levels, district, but why the district, the top is city, the figure. I don't understand why you name the city instead of, the whole province. I don't know. Okay, so maybe you can explain that a little bit. Okay, so finally, I think I believe you are going to submit these 2 articles to journals. So you should also, like your tables, some of the tables are following the APA format, and some of the tables are, still, not following the format. So probably you also need to change that. Then my final question will be, so Dadan, you are only here for master thesis for 1 year, right? So within 1 year, you actually learn all the Bayesian, and of course we already got the data, right? So maybe you can reflect on that. How was the journey, okay, for the past year, okay, in terms of doing the Bayesian analysis and all that, and also you are the incoming doctor student, and after finish your master thesis, so do you have any other future plan? Okay, so Shen, do we want to ask separately then he answer, or we want to ask together, then he answer together? What do you think?
I think he can answer yours,
Okay.
and then we'll move on to Professor Ben and then.
Okay, sure. All right.
Yes.
Okay.
For the number 1, is it only gender? I believe they still have another dimension that we can explore. But for now, we only have the data on the gender, because gender is kind of more addressed to the individual Actually, we also can explore whether the school area, but that one will focus on level 2. But for now, we focus on the level 1, which is the easiest one. And then the other question is, according to the table in the district, why I mentioned the city of I believe the city is Meiyuan. So the data is coming from the Sichuan province, but according to my analysis, so the data is coming only from one city in Sichuan province, which is Meiyuan city, as I remember. And then in Meiyuan city, they have several districts, and several cities, they have 7 districts. As I analyzed the data.
Okay, because maybe my memory. So Qilong, is it from the whole province? I forget. Do you still remember the data? According to the poster, is that one like big Chengdu city or Chengdu area or Chongqing, or it's from the whole province?
Whole province in Sichuan, but most of the schools are located in Chengdu.
Chengdu?
Yes.
But it's a Chengdu big city area.
Yes.
Oh, okay. So maybe that part I can understand now. So because it's actually from the one of the major cities in Sichuan, Chengdu area. So I think we should maybe find a better word for that. Because here, because in your district label, right, you have the label, district label, you have a city, county, rural, right? Then you also, but you still use the term city. I think maybe we should find a better term for that, right? Right. So we need to come up with a better term. Okay. So I think I need to double check with you don't remember?
Okay.
You don't? That's okay.
And for the last question,
Yes.
number 4 is about reflect on Bayesian. So I think I learned a lot for the last year about Bayesian, but actually all the years before I only focused on frequencies. So I only know what ANOVA, ANCOVA, t-test, and everything about what we call as frequencies. But after I learned about Bayesian with Dr. Shen, I really thanks to Dr. Shen. So I know more that we have a little bit problem with frequencies, and then maybe in the future I will apply only Bayesian. But in Bayesian itself, like I mentioned in our first article, I'm using Bayesian inference. I'm still using the null hypothesis significant testing, which is this is significant, this is not significant, this is strong evidence, not strong evidence. But in the second articles, I have a lot of recommendation from Professor Shen. So in Bayesian, we don't say significant or not. We say how many probability of that in Bayesian. So in second article, I didn't mention something like significant, but I mentioned mostly probability, variability. So I will learn more because actually this master thesis is only the beginning.
Yeah. So actually, Jeff, I will add 2 more. Okay. So it just occurred to me. So because when I read your thesis, so you actually cite a group of researchers from Germany in 2021. Because I know one of the authors. So from EPN, or you call it the IPN in Germany. So it's a 2021. The title of the article is Beyond P Value Using Bayesian Data Analysis in Science Education Research. I think the abstract actually already like also talk about how frequent this test has been criticized, heavily criticized for the past. I don't know how many years. Okay, and so they are suggesting how to use Bayesian data analysis in science education. I think this is probably must read article for all the, you know, the students from our group, okay? So because this is actually, it's just come out 2021. So that's the first one, and I think, you know, thank you for pointing that out. So another thing is on page 24, you cite task and referee. This is from, it says base factor, it's an American Statistics Association, right? Journal of American Statistics Association. So it talks about the log BF tool for threshold positive evidence. But that was in 1995. So almost 20 years ago. So do they have new like update, or this is kind of like a golden standard?
Actually, I read that tool of BF is coming from, I think, 2022, cited by article in 2022. So I only put the original one, like the initial threshold for the tool of BF.
Okay.
But many people still use that.
Still use that. So even though it's 20 years later, so it's kind of like, you know, they already established this kind of like golden standard in 1995.
As far as I know, tool of BF, something like that, is referred to Bayesian inference. They still use, yes.
Okay.
For the reason, I think, for the recent research, they mostly use kind of more probability, not inference.
Right. Look up the people who created JASP. The JASP people are all base factors, so all of their citations, follow their citation chain for the most recent framing, but it's not going to be too terribly different. They use the negative 2 log BF, whatever. That's one way of interpreting it. There's also the Jeffries way, and they're both in use today. So it's good. It's good.
Okay. So that's it. I finished my part. So maybe, you know, Professor John is he's taking his battery.
Okay, so here is my part. So I'm sorry, can you hear me? Because there are some background noise.
Yes.
Can you hear me?
Yeah.
Yes.
Yes.
It's clear.
Yes. Yes.
Okay. And I just mentioned that I have several issues, several questions regarding the statistical analysis. And actually, I think Dadan has did a great job because a year is not long, but he used several kinds of statistical methods in his study, including IRT and the Bayesian analysis and the traditional frequent analysis. Okay, but I have several questions. Some of these questions require Dadan to defend or reply so that I can have a better understanding of the rest content. And the first question is that, by the way, I think the scientific inquiry ability is important, and especially Brian Chen in this topic. As we already know, Brian Chen is quite a serious issue because the weather is very hot nowadays, but before it is not that hot, so I think it is important. And the assessment framework is quite nice. Okay, and I have one question. So in your study, you use a Rust model to evaluate the difficulty, or you might say discrimination. So is that correct?
Yes, bro.
Okay, so the reason why you use IRT, especially the Rust model, is just used to test whether your item has high variability and reliability, right?
Right.
Okay, so I got it. So in your thesis, you mentioned about BF. So can you talk more about why we use BF in a Bayesian analysis?
Right. Okay, Prof. So basically, BF is stand for Bayes factor. BF is one of the option to make some interpretation of Bayesian analysis. In traditional way, we use kind of p-value. For example, is p-value less than 0.05, which means it is significant. But in Bayesian, we use Bayes factor, which means we have the support from hypothesis alternative instead of no. For example, in my case, BF show the number of 500. So 500 means we have 500 times more support for alternative hypothesis. It's more like probability of the supporting alternative hypothesis instead of p-value problem.
Okay, so can I say that the reason why you use a BF is just to compare the different groups? Is that correct?
Yes, Prof. To make some comparison between gender in the first article, compare between gender and then school area.
Country, school
Right.
area. Okay. So compare with the Rush model. Rush model is used to test, it focuses on the item, but the BF, the Bayesian analysis, is based on the group comparison. Is that correct?
Right, Prof. They have two recent question. Yeah.
Okay. So if you use Bayesian analysis to compare things, why do you need to use t-test again? But in your manuscript, it seems that I saw several times that you use t-test. Why?
Test.
Yep.
Or maybe I think they are article 2 in measure the outcome, which is p-value, right, Prof?
Okay, so please go to, if you have the PDF file, please go to the page 24. Near the bottom, it says that as demonstrated by hand 2018 compare, and then there are two tests. The two key tests. One is E with degree of freedom 103 is equal to negative 2.66. So that's what I'm talking about. I don't understand why you need to use t-test here. Or this is just an example that you try to illustrate the differences between the t-test and the Bayesian analysis.
Yes, Prof. I only mentioned here to make some. This one is part of literature review.
Okay.
So here I compare between what we call as frequentist statistic. Like in classical t-test, we use p-value, and then in Bayesian t-test, actually Bayesian also can be used like t-test also using.
Yep. Okay, so I suggest you can put some words here to emphasize that this is just a comparison between these two methods, not the real statistics that you use in this manuscript. Okay, so next one, if you use Bayesian analysis, how about effect size? Because if we use an ANOVA or t-test, we can evaluate the effect size. But with Bayesian analysis, is that possible for you to show the effect size so that your reader can understand the differences between two groups?
I think as far as I know, I never see some patient they use. Oh, let me think. I think it can be possible, but as far as I know, I never see some article using patient and then they put some effect size on the.
Yeah, so I think this is a quite good question, right? So like I know Cohen's 1994 paper, Earth is round. Why I always refer to that paper because Cohen that paper like lay out everything, okay? And of course he says like 20 years ago it's been there, heavily criticized. So he proposed several strategies to not only complement, like to make the scientific inference better. So one of the suggestions, okay, according to his classic work, one of the is actually effect size, report effect size, because the effect size is the mean difference divided by poor standard deviation. So it has nothing to do. To me, it's more like a more descriptive statistic, but with effect size. So, which means like maybe Professor Zhang's question got me to think maybe she can answer that. Like, why don't people report Bayesian, but then they can also report effect size? Because effect size itself doesn't really, it's actually not doing the inferential statistics.
So I've only, of all the Bayesian papers I've published, one of them has effect sizes in it, and it has effect sizes in it because the editor of the journal demanded it. And in order to estimate the effect size, you just get the average, the mean difference between the posterior medians. But effect size is contingent upon the concept of a singular estimate of effect, so a point effect. But in a Bayesian analysis, there's no point estimate. So there's no difference between point estimates. There are distributions that encompass magnitude, direction, and precision of the estimate. So they're distributions. And so the closest you get to an effect size is in study 2. Dadan shows the average treatment effect, which is it's actually the difference between two distributions. So you take the posterior distribution, assuming a certain time, and subtract the posterior distribution, assuming another time, and instead of an effect size, it gives you an effect distribution. That's the nearest you get to a Bayesian effect size, as I've at least learned and integrated it into my own work, and therefore would have taught it to Dadan, and that's figure 4.11. So that's the nearest you're going to get. Figure 4.11 is on page 67. It's mislabeled, by the way, which is one of my comments, but ignore the label per se, but it's the posterior predicted difference in the number of scientific inquiry points scored is what this is showing. It was appropriately interpreted in the discussion, the oral presentation. So even though it's mislabeled here, you said it correctly out loud, which is I'll give you brownie points for that. But that I don't want to steal Dadan's time, but there's no point estimate per se unless what you're really doing is just comparing the medians of the two distributions. But if that's all you're going to do, you probably shouldn't take a Bayesian approach anyway, because you do the Bayesian approach to get the posterior distribution.
I see. Okay.
Yeah.
Okay.
I think this is a great solution. The reason why I mentioned this issue is that, as you already know, in APA, it says that we have to tell the reader the effect size, right? But this is based on an ANOVA or t-test. But in APA format, it seems that it didn't tell us when you use Bayesian analysis what parameters or what values are necessary. And if
Right.
we, yeah, and if
Now-
we, yeah, please.
John Kushke recently published a paper in Nature around the guidelines for Bayesian reporting Bayesian data analysis. I believe it's a 2019, maybe 2020 paper. 2020, I believe. I'll send the link around.
Okay, could you post it? Okay,
Yeah.
all right.
And so, but that's one person's opinion. He wrote a book, a very popular book, but he's one person. I will say that the journal that demanded I put effect sizes in the Bayesian paper was an APA journal. It was literally a journal published by the American Psychological Association. So when I submitted my Bayesian analysis to that journal, they were like, well, put the effect size in because we want an effect size. And I said, okay, because
okay.
it's going to be published.
Yeah, but however, Shen, are you saying that, that effect size, the idea, are actually quite, totally different from the, Bayesian distribution? So when you put them together,
That's right.
they are actually, they are doing totally different things. Is that correct?
They're answering different questions.
Okay.
And making different assumptions.
Okay.
And so, don't throw them out. If you need to use a certain approach, and if you generate effect sizes, incorporate them into your decision making, but they're not the end of the conversation. And so they're useful information. We should never throw information away, especially if we're trying to use that information to make good decisions. But they're not the only information that we need to make good decisions.
Okay.
I agree with Dr. Shen's suggestion, and the reason why I mentioned about this is that if you publish these thesis into journals, then maybe the reviewer is not familiar with the Bayesian analysis. So basically, he will imagine something that might be similar to traditional analysis. Then he or she might ask for something like effect size. So suppose, I think maybe in Bayesian analysis there is not a real effect size, but maybe we need to convince the reviewer or the reader by propose or by citing some article or some values that are commonly used in this kind of analysis. Okay, so this is my suggestion.
Yeah, so this is how Shen, when you submit the paper, the viewer asks you the effect size. I can tell why. But
I was made aware of this 2021 Kushke paper when I submitted the +1 with one of my colleagues. She worked for the CDC, but she was originally from NTNU.
Oh.
She was a research associate in NTNU many years ago.
Really?
And she's Zoe Gao. She's now a PhD and she works in America. But we did a Bayesian imputation paper that we submitted to +1 and was accepted. Our reviewer asked us to make sure that we reported our findings through these guidelines. So now +1 reviewers who are Bayesian reviewers are starting to use the Nature guidelines for Bayesian reporting.
Oh, wow, thank you so much for such a good reference. So how about the paper you submit, they ask for the effect size. Can you share the paper with us as well? In that way,
it'll be open access publication very, very soon, so I'll share it.
Okay, please share that with us. If we encounter the same thing, maybe we can, imitate.
Yeah. Okay, so is it okay? Can I go to the next issue?
Yes.
Yes.
Okay, so the next issue is a suggestion. I suggest that be careful about the consistency when you have several statistical methods, because for what I am looking here, you use IRT to test items. You also estimate distribution by patient, and there are some descriptive statistics. And you also compare means of groups. And if I am a reader, maybe I might be confused by this so many methods. In other words, I will have a higher cognitive load when I read this paper. So maybe you can use a diagram or table to illustrate your plan for your statistical analysis. For example, you can say that for the variability or reliability of items, I use IRT, etc. So if you use this table or diagram, I think your reader might be easier to continue reading the rest of the part. Okay, thank you. And so there are several. Sorry. And you have measured the outcomes on page 53. You have measured the outcomes using several thick index, AIC, BIC, log, likelihood, something like that. But my question is, which one you really use to find the differences between model 0 and the model 1? Or you use every indexes I mentioned? I saw there is a p-value here, right? P-value is smaller than 0.001. I don't know what index will lead to these p-values. Are you using AIC or BIC or others?
I think using all pro.
All of them, but they just produce only one p-value.
Because this one using R Studio, so
yeah.
we just compare M1 using kind of code, and then we compare M1, M0 and M1, so we have the D value. So I'm not sure actually, because the code, yes.
I think that maybe they just based on one of these index, because although they are very similar, but to be clear, I think you need to specify which index you use to do this analysis. I think that will be much clearer for your readers.
And this is, I can speak to this. This is from, I know the package that was used, and so from the LMT package. And what that is a likelihood ratio test on 4 degrees of freedom. So it just compared the likelihoods of the two, which is equivalent to comparing the log likelihoods. So it's the ratio, it's actually the ratio of the log likelihoods, or really subtracting out. The ratio of the likelihoods is the subtraction of the log likelihoods. So it's just the subtraction of the log likelihoods on 4 degrees of freedom. So it's a standard likelihood ratio test, which is the most basic one. I actually don't know of sampling theory or distributional theories for the AIC and the BIC that allow for point hypothesis testing on them. There may be robust ones that I'm not aware of. So I think that the software always defaults to the likelihood ratio test, which is what the actual hypothesis test is on. And it gives the AIC and BIC, which are their information criteria, like the -2 log likelihood would be, as reference to see the degree to which the complexity of the model is biasing the hypothesis test. So you've got to look at all of the evidence altogether. But I never look at p-values, so I am concerned.
Yes. I think the AIC-BIC is very similar to log likelihood. It's based on the chi-square analysis. And the difference is that the AIC-BIC will address the parsimony issues. In other words, they will penalty if you have more parameters. So I agree with Professor Shen's idea. I think the most likely index used is log likelihood here. Okay, so thank you. And so this issue is done. And so So in your study too, you mentioned the Poisson distribution. Is the reason is that you use a Bayesian analysis to estimate, and then the posterior distribution converge to a Poisson distribution. So that's why you said that your item serves as a Poisson distribution. Is that correct?
Yes, Rob. So basically, first we have the data, and then we try to find what is the distribution of our data. So first we try using Gaussian, which is a linear normal, and then it is not fit with our data. So we decide to use another one, and Poisson is fit with our data.
Okay. So I think I am done with all the major issues, and I have one minor issues is that on page 52 there are several diagrams. You show the plot of scientific inquiry ability score, and I think this plot is a little small, so that I can figure out what is the value and what is the meaning of this plot. So it is good if you can write more about this diagram and use a larger plot to demonstrate your idea. So this is my suggestion.
Right, I think this is a very good suggestion. Usually, the figures, the caption should describe what are the major points of the figures. But here you are only saying the school level, district level, class level. But there's no a little bit description regarding the significance of these figures.
Okay, so that's it. So my conclusion is that this is a quite good study, and I think Dada has done a very good job, and I hope my suggestion can improve the quality of your data. Okay, that's it.
Thank you, Rob.
Thank you. Those were great questions and suggestions. My feedback, I wanted to actually mirror what Professor Lin said in terms of the timeliness of the topic. So here in America, my good friends at Arizona State University, it's been over 110 degrees Fahrenheit for 19 days in a row.
Mm-hmm. Wow.
It's super
It's very hot.
Where?
Every day. In Arizona.
Arizona. Wow. Wow.
In Death Valley, it's going to be 138 degrees Fahrenheit.
Wow.
So it's insanely hot. And then here, where I live, we've had flooding events every week. We've had massive storms. So the intensity of the storms are increasing as well. I was really, really intrigued with the titles of your chapters. I thought that was a very nice touch, tying the titles of the thesis chapter back to the main points, the major issues around climate change that you want people to understand. So I thought it was meta and very creative. I enjoyed that. I have, I think, 3 bits of technical feedback to give around the paper. And the first one is, if you go to page 56 and you look at your distribution for the Gaussian model, I can tell what you did. You started with the Poisson model and you reverse engineer a Gaussian model from it, but it's missing key components. So it's not actually a normal distribution on page 56. It's not a Gaussian model. Because what you have is actually a model, what's called a block likelihood model. It's attempting to predict normal distribution. That's not what you fitted in R. So I'm going to share my screen. Yours won't look exactly like this, but yours will look similar. Should look similar to this. So I just typed this in Word. So we'll see when it loads. Okay. So a linear, a Gaussian model, the likelihood function is normal. But a normal distribution has 2 variables. It has a mean and a standard deviation. That's why we like it so much, because if those are the only things we know, then a Gaussian model fits it very, very well. So you have more, I just used one cluster variable, you have many. But your model would look more like this, where you have a mean and a sigma at the student level, the individual level. You have your different cluster level intercepts with their various just priors, hyperparameters. And then you should have you should have one model sigma and then one cluster sigma for every, which you have. You have the correct number of cluster sigmas. So what you're missing in your model is this part instead of Gaussian lambda. And it's just mu, it's not log mu. It's not a log linear model. Your Poisson model is a log linear model, but the normal distribution is identical, the Gaussian distribution is identically linked. So there's nothing in front of this variable. In other words, I'm going to email you this, and yours should look more like this. Cool? Okay. So it's a very minor technical detail around the way that you parameterize your Gaussian, your normal distribution, on page 56. On page, and then also the fact that you're missing your model level sigma because of it. Two very, very easy things to change. It'll take you 10 seconds. Now, page 57, in part of page 57, actually I'm going to share my screen so I can show you exactly what I mean. You say the right thing and the wrong thing about the same thing on the same page. It's beautiful. Okay. So above figure 4.6, you correctly interpret what the Pearson correlation means in terms of marginal variability explained. Perfect. But when you say it again, down here, you say the Pearson correlation is 0.56, which means 56% of the variability in the scores. No, it's 31.
Yeah.
You got it right up here.
Yes.
So it should say 31% here as well. Make sense?
Yes.
See, you got it right above. Say the right thing again. And then, like as I alluded to, then also on page 67. Here, this is the posterior predicted total score between average scientific inquiry ability and triggered interest by testing time. Actually, it's the posterior predicted total score between students with high and average testing times. Because as you say and as you show in your code, it's between a time that is value 2 standard deviations above normal, and then a time at 0, which is normal because you standardize time. So this has nothing to do with the median log odds of anything. It's the posterior predicted total score difference between high and average time students. Make sense?
Makes sense, right?
So it's a much easier interpretation. You don't have to bring log odds into it at all. Your interpretation of it in the paragraph that follows is correct. So you say it correctly here, but you label it incorrectly. The two should be different. And other than that, that's pretty much all I have to contribute in terms of technical feedback. As I said, I'm leaving study one more to, I know Professor Wynn's got chops in psychometrics and understanding ICC and all that fun stuff. And honestly, I was just really impressed with the care that we took in study one around instrument development, around a very complex topic. So the care that you took and the fact, and I don't know the degree to which you mention it, but your findings in study 2 around gender and variability between level of school organization, and the fact that you see more between district level organization variability than you do at the lower levels, is actually concurrent with your findings. It expands upon your findings from study 1. Because in study 1, you look at like levels of urbanicity, which is highly correlated with districts. Districts are in different types of zones. So you're finding similar spatial trends in both studies, which is good. They support one. It's good when your studies talk. All right. But that was it. So I'll send you this Word document at the conclusion so you have an example of the Bayesian likelihood and those priors that you need to actually talk about your linear model that you use before using the truncated Poisson model. And to also piggyback and further answer the question to Professor Lin, the outcome variable in this case was simple count data. Count data are Poisson distributed, so the data generating process can be assumed to be Poisson or negative binomial because it's rare event occurrence count data. If it's count data but not rare events, then that distribution looks pretty normal. But if it is a small number of items, then it could conceivably be Poisson distributed. But that's it. That is everything I have to say. I'm going to make sure I say this one.
All right.
And then any closing or additional comments from the committee?
Hey Shane, hey Professor John, could you like turn on your camera
Okay.
I want to print the screen.
No problem.
Okay, so everybody in the okay, hold on, okay, hey, Dadan, you need to get
now.
Okay,
Yeah.
I want to capture a picture.
Yeah.
All right, 1, 2, 3. Okay. One. Okay. Wow. Okay. All right.
Cool.
Okay. Good.
Okay. Now, at this stage, as the committee, as the chair, I'm going to invite everyone to leave again, so that the committee can debate the outcome of the. Okay. So, as chair of the committee, it is my responsibility to communicate the results of our decision pertaining to the thesis and the defense. We have decided unanimously that Dadan has passed his defense, both from the perspective of the strength of his work and his responses and his oral presentation. They were all very, very strong. We have, all three of us have minor edits that we are requesting that do not impact the decision of passing the thesis. The thesis has been passed. And so, yeah, round of applause immediately. Having passed it.
Congratulations.
So, before we adjourn the meeting, I wanted to thank you all for including me on this process and letting me work with you, Dadan, over the past year as these questions have kind of developed over time. These studies have developed. I would like to tell you then the next steps. So what you're going to do next is, in the next few days, you'll make the revisions that we've requested for our conversations. And then when you've made those final revisions, you will send me a copy. Then I will check that the revisions have been completed for the conversations we've had here today. And then I'll alert the rest of the committee. We will sign your forms and you will be good to go.
Okay, great.
Any questions?
No.
No?
No.
Okay. Congratulations.
Congratulations.
All right, congratulations, Dadan. Okay.
Okay.
So Shane, thank you so much. So it's almost 11 p.m. Tonight.
Okay.
All right, thank you, John. See you on Monday.
Thank you. No
Okay.
problem. Thank you.
Okay, bye bye. Bye bye.